Hello everyone, I'm Khalid and I'll be your instructor for this Python course provided by LearningWhilePracticing. In this video, we'll be talking about mathematical and string functions in Python. So let's get started. So let's start with a mathematical function in Python. And in order to use most of the built-in functions for math operations, we need to import or use some existing module in Python. And this module is called math. In order to do this, we can just write this statement. So from math import asterisk. So this is just importing all of the content of the math module into this program in order to be able to use the different functions existing in that module. So the first function that we're going to use is called ceil. So this function takes some floating point number. Let's say we have a floating point number which is x and the value is, let's say, 10.9. So the ceil takes the number to the next integer. So this is converting it to an integer, and that integer will be the next value for that number. So if we do ceil of x and print, then run, that would be 11. So this is 10.9, and when we do ceil, that would be 11. The opposite for this function is called floor. So if we do floor of x and run, that would be 10, which is this number without the fraction part. And another interesting function is the power function. So if you want to raise some number to a specific power, there is an existing function for that. So this function is called POW or power, and it takes two arguments. The first argument is the number itself, and then the power that we need to raise it to. So let's say we need to calculate x to the power 2. So this is how we write it. Let's make x a simpler number here. Let's say it's 5, and then we'll print that out. So when we run this, we find that the value is 25. We can do the power using another different method in Python. We don't even need to use the math module at all. So there is this power operation or the power operator in Python. So in order to do the same thing, we can just type x 2 asterisk and 2. This is exactly the same except for one small difference. If we run that, we also get 25. So the difference here, if you notice that this number is a floating point number, it has a fraction part of it, although it's 0, but it still counts. This one, it's only an integer. So this method returns only integers. By using the power function in the math module, returns floating point numbers. You can also make sure that this is the case by using the type function here to see what is the type of this result, and then run. And as we mentioned, this is a floating point, and the second one, this way, returns an integer number. Okay, so let's move on to the next function, which is the factorial function. So the factorial takes a number, let's say x, and then it gets the factorial for this number. So the definition of the factorial is just x multiplied by x minus 1 multiplied by x minus 2, and so on, all the way down to 1. So if we print that value and run, so this is 120. So that is the factorial. We can also use log function. So we have log to the base 2 and log to the base 10. So let's start with log to the base 2, and let's have a number like 512, and then print that, run. So that's 9. Why it is 9? Because 2 to the power of 9 is 512. Let's try another one. 1024, run. So that is 10, and so on. We can also use this log to the base 10 function, and let's give it a number like 1000. and run, we can find here that the value is 3. So why 3? Because 10 to the 3 to the power of 3 is 1,000. Sounds good. Let's move on to the next function. We have the square root function. Of course, it takes a number and finds out the square root of that number. So if we have 25 and we print the square root for that number, run, so that would be 5. And try another number like 9, that should be 3, and here we go. Another popular trigonometric functions are like sine and cosine. We can use them. So in order to use sine, we just type sine and then it takes a radian degree. So what if we don't know the radian degrees, or I'm sorry, the radian angles, because degrees are more popular? We can also convert degrees into radians using radians. So we have a method, a function called radians, and it takes degrees. So here we have the radian representation of 90 degrees. And this is an argument to the sine function, and we need to find the value of this sine. Let's run. So here the value is 1. We also can do the same with the cosine function, radians 45, for example, and run. And here we go. So sine and cosine, very commonly used function, might be very useful. We also have that constant pi, which is very popular in mathematics. There's a high chance that you'd be using it if you're doing some mathematical operations. So if we just write pi and print it, we know the value that would be expected, this value. So let's use it in a useful program, small program. Let's say that we need to calculate the area of a specific circle, and we have the radius for this circle. Let's say this is r and it's 2.5. We need to calculate the area. So the area is just pi multiplied by r raised to the power of 2, right? So in order to do that, we have learned the power r and 2, and then we print area. If we run that, here we find that the area is calculated as per the equation we have provided. Okay, so that would be it for the math part, and let's move on to the string functions. So we have looked at strings before in our very first program where we printed the hello world. So hello world there was our first string, so we can have a string defined as this hello world. Of course, we can print that as we have seen before, and if we run, it is just printing this string. So this is a string, and it will be enclosed by 2 double quotations, or enclosed in a double quotations. But we can also use like single quotes, and it will still work. Okay, so the next thing is that we can also have like very long strings that take many lines. So in order to do this, we need 3 double quotes or 3 single quotes. Both of them would work, and then we can start writing down our string. So let's say this is a very long string that extends many lines and can even go further. Let's print y and see what would be the output. And it prints exactly the same way that we enter this in our source code. So that would be a very good thing to notice. We can have like strings that span multiple lines. We also need to know that strings are considered like arrays of characters. So we can access individual characters within this string. We can access this specific character, we can access that one. So how do we do this? We access them using indexing. So each character within this string has an index. So this character, the first character, has an index of 0. This one, the second character, has an index of 1. And the next one has an index of 2, and so on. So in order to get the first character of a string, we can just print x of 0. That prints the first character. and yeah, it prints the first character of our string. We can also do this, let's say x of 4, so that is the O letter at index 4, and so on. We can also do some slicing within the string if we need to print or have some substring stored. We can, let's say we have a string str1, and that string would be x, but only from indices 1 through 7. And let's print that out. Print str1, run. We find that this is a partial string of the original string that we had before. So what does this mean? So that means that we're constructing a string starting index 1. So index 1 here is E to index 7, but not including index 7. So if we go over here, we can find that index 7 here is O, as we looked at this before, and it doesn't include the character at that index, so it basically stops at the previous one, which is W right here. So slicing, that is slicing. We can also know the length of the string by using this function len, or length, and just pass the string name. So let's try it with str1 and run. We didn't print that, we need to print it. Let's print and run. So we can find that the length here is 6, which is expected here. We know how we constructed this string. Another function is called upper. So this function converts all of the letters of a string, let's say here x, to upper cases. And then we can print that. So we can see that all of the characters have been converted into uppercase. And also have lower, which does the exact opposite. So all characters here have been converted into lowercase. So that would be it for strings and mathematical functions for now, and hopefully see you on the next video.
Hi, this is Joe from Learning While Practicing. For the first exercise of Chapter 3, we are going to see some of the math functions in the math module of Python. So we are going to open the very first code in PyCharm. So first of all, of course, we need to import the math module in order to use these predefined functions. And here we are just going to see a few of the many functions that we have. 4 algebraic functions and 5 trigonometric functions. So here we have the exponential functions, okay, which allows me to do the exponential of a certain value. We are going to see the logarithmic of a certain value as well. So it's a log with a basis exponential. We are going to see the log basis of 10 and how we use it, so how we define it, and the square root function. As for the trigonometric function, we are going to see the sine, the cosine, the tangent, and how to go from degrees to radians. Okay, so we are going to see how we translate these values together. So we are going to run this in a new project. Okay, so this is the one that we have, math functions. We're going to close the previous ones and just here diminish these right here. And now we are going to run this program, math function. So here in the output, you have first of all that the value of an exponential taken to power 1, so the value of e is given by 2.718, etc. So this is the value of the exponential in the math module. Then if you do the log of 2.78, meaning the approximation of this one, so actually math log of math.e.exponential, so the perfect value, if you want, of the exponential, you obtain, of course, 1 at the same basis. Now, if you want to carry out a log basis of 10 that you have right here, so here the log value, it takes, first of all, the base, you need to specify the base that you have, and then you need to specify the value that you want. So here you have, for the log value, you need to indicate the basis and you need to indicate the value. So of course, if you're at basis 10 and you use the value 10, you're definitely going to obtain 1. Then you have the square root function. So of course, square root of 4 will give me 2. So this is an example of these algebraic functions in case you need them. Then you have the sine function. So of course, if I do the sine of pi over 2, I obtain 1. So here, keep in mind that the angles for the sine, cosine, and tangent function are in radians. They are not in degrees. So all of these right here are values in radians, so in factors of pi. In case I want to translate something in degrees, I'm going to go and use the degrees function, which is going to convert an angle x from radians to degrees, as you can see right here. So here you have the explanations whenever you hover over a certain value. And here, when I use the radians function, it's actually to convert an angle from degrees to radians. So whenever I want to use an angle in these functions, it needs to be in radians. So in case I have a value in angle, I need to, first of all, transform it into radians. And so this is an example in this first video of the different elements, some of the elements contained within the math module. So I'll see you now in the next video. For the second exercise of chapter 3, we are going to see a program that computes change. So let's open this program together. So here we have, first of all, an amount that has to be input by the user. So this is a float value. Then this amount is converted in a new variable. Remaining amount is equal to the integer of amount times 100. What this does is that it's going to transform our amount in cents once I multiply by 100. So I have the total number of cents. Now, as you know, every 100 cents is $1. So in order to find how many dollars I have, I need, in my new variable number of $1, to divide the remaining amount by an integer division by 100. And then remaining amount will now be equal to remaining amount with the percentage 100, meaning the remainder of the division by 100 of this value. So this should be a value of 99 and less. Or, of course, it can be 0 if it's purely 100. But basically, we say it's 99 and less. Then I need to find the number of quarters from these. So I find the number of quarters, and then I shall have something with 24 and less. I find the number of dimes, and I'm going to have a number with 9 and less. Finally, I find the number of nickels, and I'm going to have something here with 4 and less. And this number, which is 4 and less, will be the number of pennies. So here the math is pretty straightforward. That's not complicated to do. Now, the only reason I'm really interested in showing you this particular program is not for the math itself, but rather for the printing options that you have. Here you see we have \n and \t. We are going to see what both of these do in our printing output and why they are important. So we are going to run our program into PyCharm, the compute change. And here we need to input a value. We are going to write, for example, 12.05. So for 12.05, we find that this is $12, 0 quarters, 0 dimes, 1 nickels, 0 pennies. So you see how beautifully all of these are written out. But there's a reason why they are beautifully written out. If in case I remove the \n right here and I run the program once more, you're going to see now that there's a difference in the output. As you can see, the $12 is not anymore on the line. So here the \n is actually ensuring that I go to the line willingly. If I want to go to the line below, I need to use the \n. Now the \t, in case I remove it from my equation right here, let's see what happens. So in case I remove the \t, you see I lose the alignment. I lose the tabulation. It's like the tab, the one that you have on your keyboard. So I lose the alignment that I have. In order to keep things aligned, the \t is what will allow me to have a beautiful actually output in my printing. So that's the reason why I wanted to show you this program. All for these, in order for your print not to have to be on the same line, but it can be as if I had a table. And you see that once I do this table, I can have things that are perfectly in order. Okay? So that's basically the reason why I was interested into showing you this program right here. So we'll see each other now in the next video. The third example that we are going to see is about drawing shapes in Python. And not just any shape, but you can draw particular shapes that are already pre-programmed and very easily. So we're going to open this program right here into PyCharm. So first of all, of course, we have to make sure to import the turtle module. That's the first thing. Second, there's a function in Turtle. We can change the pen size if we want. So a pen size of 3 means the thickness is now 3 pixels. We can change it to any value that we want. Okay, so there's, if you want, several options to enhance the way your visuals will appear in your program. Now, all of these you're familiar with them. Now, for the circle function, as you see, you can set the radius right here, but you could also set the number of steps. And the number of steps will actually correspond to the number of angles that you want. So the function circle right here not only draws a circle, but it draws any shape, any closed shape that you desire, and you can specify the number of steps for that closed shape. So, for example, if you mention 3 angles, you're going to have a triangle. 4 steps, a square. 5 steps, a pentagon. 6 steps, an hexagon, etc. And if you don't mention anything, then it's going to be a circle. Now, keep in mind that nothing does not mean steps equal 0, because 0 is something that will give you an error. It's not steps equal 1 because 1 means a point, and it's not steps equal 2 because otherwise it will give you a line. Okay, so not mentioning anything for the steps will by default draw a circle. And let's see together that program and how it works on PyCharm. So I'm going to run this program, the simple shapes, and here you go. These are the shapes that I have. So this is the triangle, this is the square, this is the pentagon, this is the hexagon, and this is the circle. So you see the thickness here can be changed due to this option right here in pen size. And we are going to see now in the very next video another example of how to enhance these shapes and how to give them color. So now for the final example, we are going to see how these previous shapes that we have seen can be enhanced. So we are going to open this code right here that we have. And this code has now been enhanced in order to incorporate the fill option. So the fill is also a function from the turtle module. So what we have done, first of all, is we have started a fill and we have changed the color that we want. And once we have finished drawing our object, we need to end the fill. So we begin to fill the color and then we end the fill in order for the whole shape that we have to take this fill color. And what we have done here is that we have changed all the colors for all the shapes. Now, in the end, once we finish, we have changed the color to green. We went to a certain point, and once we reached that point, we put the pen down and we have written cool, colorful shapes. Now, keep in mind that, as I told you, the right option does not necessarily need the pen to be down. And we're going to see that right now. And then when I hide the turtle, I'm actually hiding the cursor. So let's see how that program works right here. So color shapes, this is the one. We are going to run it now. So you see now I have beautiful colorful shapes. So in case I remove the last pen down right here, it should not be affected for the writing. So I'm going to run it once again. So you see, it does not affect anything because the writing is not affected by whether the pen is up or down. Okay, so just so you know, this does not change anything. Now, as you can see, once I have written, I can also change the font. I can change the font by the first option. I can choose where I want Times, Arial, the size, and if I want it bold or not. Okay, so these also are interesting options that I have. Okay, so I'm able to draw something with a fill in. I need to begin the fill and end the fill at the end, and I can choose the color that I want. So let's see that one last time, this beautiful example of these 5 colored shapes. Okay, so you see, that's what I really love into Python. For example, the ability to have something graphical very quickly. We've just started this course together and you can already do things graphically. That's the beauty of using Python, as well as many of its powerful tools and modules. So I hope you enjoyed these 4 examples, and I will see you in the next videos.